Hi students, welcome back to today's class. Today we are going to see about types of stack item nodes and conversion of infix expression into a postfix form, and then some of the stack applications we are going to see in today's class, and polystrings also. So polys notation means that is converting infix to postfix or prefix notation only. So that also we are going to see here in this stack topic. Okay, so in the previous class we have discussed about different type of data structures which are used in Python, and stack we have started. Okay, so application of that is how we can implement the stack and what are the operations involved in the stack and all we discussed in the previous class, and the stack implementation using list array also we have seen in the previous class with the help of Python code I have explained. So now we are going to see the applications of stack and types of stack item node means what. So that also we can see now in the today's class. Okay. At the end of this session, you will get an assignment related to infix expression to postfix expression. So you need to convert the given expression, that is infix expression, into a postfix notation or postfix form. Okay. So for that we will discuss some of the examples now in this video. So first one, type of stack item node. So what is meant by an item? Okay, an item stored in a stack is also called item node sometimes. So whatever item or value we are storing in a stack, it is also called as item node. Okay, in the above implemented stacks, so that is in the previous implemented stacks and all, the stack contained item nodes containing just integers alone. So only the numbers alone it was used. Okay, so the stack was used by only the numbers. Okay, so stack was holding only integers numbers. If you want to create a stack that may contain logically group information such as member details, like, okay, so member number, member name, and then age, member age. Okay, so this logically grouped information, if you want to store it in a stack. Okay, for such a stack, the item node will be a list containing the member details. So you need to have a data type list. Okay, so item node will be a list containing the member details, and then this list will be entered as an item into the stack. So this list is only going to be, because if you want to enter the logically related information into a stack, so you need to have a member details. Okay, so the list will be containing member details, and then this list will be entered into the stack as an item. So let us see the first example, the first picture. So in this first picture, we are having stack of integers. So only integer values are stored inside this stack. So item node type is what here? Integer, because we have stored here only integer values. So what is the bottom element of the stack? 7. What is the top element of the stack here? This integer stack? 3. Okay, so because 3 we are inserting now, so after inserting 3, 3 will become the top position. Okay, now second picture is showing that is B, stack of characters. So here this stack is containing only the characters. So how we can identify the characters? Character data type, that is string data type. Whenever any alphabet or alphabet with number or number, if it is mentioned inside the single quotes or double quotes, that is considered to be a string. So the here item node type is string here. So this stack is called as stack of characters. Okay, next one only we are having list. Okay, list data type. So stack of logically related information. So one student detail, if you are taking, one particular student or next student, so like that student details, if you are considering, that is logically related information. So what information you will have in student details? Student name, roll number, student date of birth, and his address, all those information logically related. Okay, so this kind of information if you want to store, because list will hold different types of data. Okay, so if you want to mention different types of data, if you want to insert in a stack, you can use list data type. Okay, so if you want to mention logically related information in a stack, so we need to go for a list data type. Okay, so if you consider the first item here, list item here is 13 comma then string then comma 35. So integer and string together, it is mentioned here. The next also list only we need to enter. So this is fully having list values. Okay, so this stack is holding only list items. Okay, so next one is that is 9.6a figure. It is showing that the stack will be implemented as stack of integers as item node is of integer type, because item node is of integer type, so that stack of integers we have implemented. Second one is stack of strings, because item node is string type. Okay, and third one is stack of list, because item node is list type. Okay, next one, stack applications. Okay, so applications, above one number is mentioned, so that number, that is showing that other applications of stacks also that is mentioned here. So now we are going to see only one application, that is reversing a line, and polish string also, polish notation also is another stack application only. So we will see some applications here. In that some more applications we will not discuss here detailedly in this session or in this entire chapter also. So some other applications of stacks include the compilers uses stacks to store the previous state of a program. So if you have studied this compiler topic, no, clearly, so you might have known that compiler will be using different states, in order to check the syntax of the program. Okay, so compiler is used for, normally in any programming language, it is used for checking the syntax of the string, whether the program is written according to the syntax. Everything will be checked with the help of the compiler. So the compiler implementation, stack concept is going to be used. Okay, so compiler uses stacks to store the previous state of the program when a function is called, or during recursion. So during recursion time, or when we are having a functions topic, no, so we have studied functions topics, no, so when a function is called, what was the previous state, so that state is going to be stored. So before the function call is made, what was the status of the that is latest values of variables, all those informations are going to be stored in a stack. So for that, compiler is using stack as a storage area. So compiler uses stacks to store the previous state of the program when the function is called, or during recursion. So this is one application, other application where the stacks are going to be used. And the second application is, one of the most important applications of stack is backtracking. So backtracking concept is one of the concept where we will apply here. This backtracking means backtracking technique is used in large number of puzzles related problems. No, if you want to solve maths puzzles and all, the backtracking technique only was used. Okay, so backtracking technique is used in solving puzzles and NPN problem, and then Sudoku, etc. are using this backtracking technique. This is also one of the implementation of application of stack only. Backtracking is implemented with the help of stack only. Okay. So now optimization problems such as the knapsack problem. So this and all you are not going to study detailedly here. So these are the some other application areas where we are using the stack. This also you need to remember clearly. Now we are moving on to application, that is first application, reversing a line. So there are several applications and uses of stacks. Stacks are basically applied where LIFO scheme is required. So in which kind of applications and all, the last in first out scheme is needed. So in that cases, stack is going to be applied mostly. Okay. So first application is reversing a line. So if you are giving one sentence, how we can reverse that sentence or a word? So that is only reversing a line. So how we can reverse, we will see with the help of example. So with the help of push and pop operation only, we can reverse the line. First we need to push the sentence, and then one by one you need to push the characters into the stack, and then one by one you just pop it out. Okay, so normally which element we have inserted at the last place, that will be popped out last, the first. Okay, so last in first out, so that we can easily get the reverse of the entered string or inserted string. Okay, inserted line we can get in a reverse way when we are doing the pop operation in the stack. So this is the application of stack, that is for reversing a line. So simple example of stack application is reversal of a given line. We can accomplish this task by pushing each character onto a stack as it is read. So when the line is read, we need to push the character by character into the stack. When the line is finished, characters are then popped out. Okay, so we need to pop up the stack and they will come off in the reverse order as shown in figure 9.7. So the given line is stack. So stack, the line only is going to be inserted into the stack. So first S is going to be pushed. Okay, push S in the empty stack. Initially stack is empty. And next you need to push the T. So T is available at the top now. And then A you push, C you push, and then push K. So the entire line is inserted now. So now I want to get the reverse of this word. So what is the reverse of this word or line? K, C, A, T, S. So if you look at the stack here now, K, C, A, T, S. So to obtain this reverse line, you need to use which operation here in the stack? Pop operation. So first you need to pop. If you pop for the first time, K will be emitted. Okay, K will be removed out of the stack. Then pop C, and then pop A, then pop T, pop S. So entirely all the elements from the stack is going to be removed. So this way we can do the reversal of a line, okay, with the help of the stack. Next is polystrings. This is also another application of the stack, is in conversion of arithmetic expressions in a high-level programming languages into machine-readable form. So if you have a high-level arithmetic expression, so normally one expression means just a plus b, c plus d, c by d, or c into d, like that. Some expressions, simple expressions, arithmetic expressions, if we are having, uh, that is going to be converted into high level language in the form of what? High level programming languages. Uh, this is going to be converted into machine readable form. Okay, binary readable form. This arithmetic expressions need to be converted because our computer system can only understand and work on what language? Binary language only. So whatever high level languages, that is Python programming languages, if we are using, in the if that programming language is involving any arithmetical expressions, so that need to be converted into binary language. Okay, so it assumes that an arithmetic operation can take place in two operands only. That is, the computer will understand that arithmetic operation can take place in two operands only, that is a plus b, c into d, d by a, for example. Okay, so two operands and one operator, so like that only it will assume. Okay, the computer will assume then. But in our usual form of form, an arithmetic expression may consist of more than one operator and two operands also. So for example, within parenthesis a plus b into c, and within parenthesis again d by within parenthesis j plus d, and then close the two parentheses. So this is the lengthier arithmetic expressions. This cannot be understood by the uh, computer if you pass the entire arithmetic expression. So this should be converted into the form of binary machine readable format. So in order to convert this, we need to go for what? Conversion of polystrings. Okay, so these complex arithmetic operations can be converted into polystrings using stack. Okay, so polystring, like that we are going to convert using a stack concept, which then can be executed in two operands and one operator format. Okay, so now after converting into polystring format, it is going to be preceded by operator and then followed by operand, or else it will be followed by operator, and then we have the that is before the operator we have the operand also. So like that it should be converted. Okay, any lengthy arithmetic expression should be converted before this is going to be used in the programming language, or that is before it can be executed. Okay, so polystring means what? Polystring named after a Polish mathematician, Jan Lukasiewicz. Okay, so Lukasiewicz, because of this Polish mathematician, polystring is named like that. It refers to, what is meant by polystring? It refers to the notation in which the operator symbol is placed, that is plus or minus or division or multiplication. That is only known as operator symbol, in which operator symbol is placed either before the operands or after its operands. So if you are placing the operator before its operands, for example, a plus b, how we can write in the form of before it operands? Plus AB, that is prefix notation. Okay, so plus AB means prefix notation. Infix means middle between the two operands, we will have the operator means that is known as infix expression. If the same operator symbol is placed before the operand, that is a plus b, how we can write plus ab. So this is known as prefix notation, because uh, after plus only the operands, two operands is preceded by plus. Okay, so that's why it is called prefix notation. Next we will have suffix notation or postfix notation. So postfix notation, in the sense, operator is going to be placed at the end of the operand, okay, after the operand. That is a plus b, how we can write in the postfix form, ab plus. Okay, that is operands after operator need to be placed. That is in contrast to usual form where the operator is placed in between the operands in fixed notation. So polystrings, in the sense, either operator symbol should be placed before the operand or after the operands. This is only known as polystring. It is the notation. The polystring is otherwise known as Polish notation or Lukasiewicz notation. So like that we will call in a different name. Okay. Next we will see one example related to how we can write the lengthier expression in infix format, prefix and postfix notation. So let us see the first one, a plus b. It is written everything here. It is mentioned as infix notation, and the second column it is denoted as prefix notation. Third column is here. It's denoted as postfix notation. So in infix notation, first one a plus b is written. So in prefix, the plus should come before, so that this is very simple to implement, so that we can easily get the answer, that is plus ab. Okay, because here we have two operands, so easily we can write prefix and postfix. When it comes to lengthier operands operators only, it will gives little confusion. So that also we will understand now. Okay, so prefix notation, how we can write for this given expression, plus ab. Postfix notation, how we can write, that is operator should be placed after the operands ab plus. Here there is no extra operands or operators involved here, so that it is easy to write. Now let us see another one more operand is going to be used, and operator also going to be used. So how we can write prefix notation for this? First we need to write, that is the last the parenthesis after which symbol is written, that operator need to be placed first. Okay, parenthesis after what symbol, that is inner parenthesis after what symbol is written, that need to be placed. Okay, okay, so now we need to write multiplication first. So into minus acb. Okay, and postfix notation, how we can write AC minus. So parenthesis you need to solve first. AC minus and then B star. Like that we need to write the postfix notation. And prefix notation for next one, A plus B into C. So here prefix, how we can write, plus AB. So here plus should come before A, and then star should come before BC. So this parenthesis is solved the next. Okay. So uh, plus A star BC is the prefix notation. How we can write postfix notation here? So first we need to write the A, B, C, and then first we need to give the importance to star and then only plus. So A, B, C star plus. Next one is A plus B division C minus D. So how we can write prefix notation here? Uh, First we need to give first parenthesis after what is symbol given, slash. So slash plus AB, okay, and then minus CD. That is prefix notation. How we can write postfix notation? AB plus slash, okay, then sorry, AB plus and then CD minus, afterwards only that slash should come. Okay, next one is A plus B star C, close the parenthesis, and then division, opening parenthesis, C minus D star B. So how we can write the prefix notation for this? First we need to write plus, that is this division should come before this A. So slash, and then after A what the symbol is present, plus is present, so that plus, and then A you write, and then star you write, then BC you write. Then the same method here also, minus C star DB. Okay, and postfix notation, how we can write, ABC star plus slash, sorry, slash will come at the end. Okay, because slash is going to be applied for both the sides. So ABC star plus CDB star minus, then slash. Okay, so like that you need to write the postfix notation. Next one is the previous example we have seen without any explanation. Now they have given the rule for converting the infix expression to postfix or suffix expression. So postfix expression, otherwise we can call it as suffix expression. So while evaluating an infix expression, there is an evaluation order according to which first priority is given to brackets or parentheses. Second priority we need to give exponentiation. So when you are converting infix expression to postfix expression, you need to follow these uh, four orders. Okay, four orders you need to follow. Okay, so first one brackets or parentheses, second one exponentiation, third one multiplication or division, fourth one addition or subtraction takes place in the above specified order. The operators with the same priority, example star and minus, evaluated from left to right. So if any operator is having same priority, that is going to be evaluated from left to right. Example star and division and addition subtraction also. To convert an infix expression into postfix expression, this evaluation order is taken into consideration. So we need to follow the first order to first priority to fourth priority. So in the same order only we need to follow. An infix expression may be converted into postfix form either manually or using stack. In a manual way also we can convert, or in a stack, the help of stack also we can convert. So the manual conversion requires two passes. So manually, if you are converting infix to postfix, it requires two passes. That means two times we need to do the process to get the correct postfix notation. One for inserting the braces, that is one pass. Another for conversion. So however, the conversion through stack, it requires only single pass. So only one single read itself, the entire infix notation is converted into a postfix notation. But if you implement the same thing in a manual way, first we need to insert the braces. Second, we need to convert it. So conversion will be second and insertion of that braces will be the first pass. Okay. Next, the steps to convert an infix expression into postfix expression manually are given below. First, we need to determine the actual evaluation order by inserting phrases. So after inserting phrases only, we will come to know in which order evaluation need to takes place for the expression. So that we need to determine as the first rule. And second one is second step, convert the expression in the innermost phrases. So innermost phrases, what expression is given, that should be converted into a postfix form, and by putting the operator after the operands. Repeat steps 2 until entire expression is converted into postfix notation. Now let us see the example of converting a plus b star c by d into postfix notation. So here first you need to, what is the first step in order to convert the infix expression into postfix expression? Determine the actual evaluation order by inserting phrases. So determine the actual evaluation. Now let us see the conversion of the following examples, that is convert the a plus b, that is inside the parenthesis a plus b is given, a plus b into c by d into postfix notation. So first step is we need to determine the actual evaluation order by putting phrases. Okay, so in the first step we have we are going to insert the phrases here. So a plus b already enclosed with parenthesis. Now multiplication after c is there. So this c first need to be enclosed with the parenthesis. So after this d only is the final element. So we will leave that final operand. Okay. So now step 2, we can convert the expressions into innermost phrases. Okay, first innermost phrases are taken. So which is the innermost phrases in this first step? AB, A plus B, that is after conversion into postfix notation, how we can write AB plus. Next into C is there and divided by D. So in the next step, AB plus is already converted. Then C star we need to write. Okay, star C should be written as C star. So this is converted now. Now only thing is remaining is D alone. So after conversion, AB plus C star, D slash. Okay, D division. So like this, we can convert the postfix notation for the given infix expression. So this is the postfix expression for the given infix expression. Okay. So next example, let us see. Convert a plus b within parenthesis, already we have opened another parenthesis also, into c, okay, slash d plus e to the power f, close the parenthesis. So this entire thing is making making the there is one phrases inside all these one parenthesis inside all these operands and operators are enclosed, so that we need to put the phrases inside this parenthesis only. So this slash g we can remove, like we can leave like this slash d. Okay, so we no need to include parenthesis for this slash g. So we need to concentrate only on the first parenthesis where it is enclosing. No, up to that we can focus. Okay, so now we need to give importance for star, division and cap and all. Okay, so let us see one by one. So first one, a plus b already is enclosed within parenthesis. Now star c we have included along with this a plus b. So that is enclosed. So for that we have opened another opening phrase and parenthesis, and then slash d also is enclosed now. For this also we have opened another parenthesis. Then for e power f alone, it is enclosed in another parenthesis. Okay, so this is having separate parenthesis. Okay, so like this we have placed the we allotted the parentheses for evaluation order of the given expression. Or it will be changed like this. Now converting expressions in the phrases. So inside the parentheses, what and all is available, innermost parenthesis we need to solve first. So which is the innermost parenthesis here? EF, and then that is E cap F, and then A plus B only now. Okay, so AB plus and EF cap, that is solved now. So EF cap in the next line we can write without parenthesis here, and here AB plus need to be multiplied by C. So C star we can write, and we can remove this parenthesis for AB plus. Okay, and now slash D is combined along with this AB plus C star. So after conversion, AB plus C star D slash. Okay, so this full parenthesis now we are taking along with plus EF cap. Okay, so now we can write AB plus E star D slash EF cap, and then this plus is moved after this cap. Okay, and then G after the slash is going to be moved. Okay, so like that we can convert the given infix expression into a postfix notation. So next you need to convert the following example. So this assignment you need to do. So you can take this expression and you need to convert it into a postfix notation. So this is given in the form of infix format, and you need to first put the evaluation order by putting the phrases or parentheses, and then you need to convert the given expression into a postfix format. So for both the expressions you need to follow the same procedure, and you convert this and send the answers to my WhatsApp number. So after conversion, what answer you are getting, I don't want that. So you need to write step by step. So first step and second step. First step, putting phrases or parentheses for the evaluation order, that expression also you need to write correctly. And then second thing is after conversion. So step by step method you need to show when you are converting. Okay, thank you. With this we will end up this today's session, and in the next session we will see some more topics related to stack applications. Okay, thank you students.